Welcome back, everyone. Today we are going deep on depth filtration.
Depth filtration.
Yep. I was thinking about it, and it's kind of wild how we can coax these tiny little cells to crank out all sorts of compounds in bioreactors.
hmm
But then you need a way to actually get that stuff out.
Well, that's right. I mean, it's one thing to get the cells working, but then, yeah, separating out the good stuff that we want from the cells themselves, all the leftover gunk.
Yeah, all that cellular debris,
Right.
the whole thing. So we've got some really cool material here. We're going to get down and dirty. Our mission, if you choose to accept it,
Two.
we're going to cut through all the complexity and really understand what is this depth filtration thing? How does it actually work? And why is it so crucial in these industrial biotech processes?
Exactly. We're going to get to the nitty-gritty of it, for all of you out there who maybe haven't heard of this before, or even if you have, this will kind of be a cheat sheet, like the essentials of this really important separation method.
Absolutely.
Oh.
Okay, let's get started. What is depth filtration? Can you give us a quick rundown?
So, imagine a filter, but not just like a flat screen. Think more of a three-dimensional maze. That's basically what a depth filter is. And unlike a screen, which only catches stuff on its surface, these guys, they're thick and porous, so they're able to actually trap particles within their entire structure.
Okay, so it's like a sponge almost.
Yeah, you could think about it that way.
Okay.
It's got a lot of depth to it, and that's why it's called depth filtration. You think about trying to filter something like, say, muddy water. If you just had a thin cloth, it'd clog up super fast.
Right.
But a thick filter, a depth filter, can actually hold a ton of that sediment, all that dirt and stuff inside of it. And it does this through a couple of different forces, a few different mechanisms.
Okay, so it's not just about size exclusion like a sieve then. It's more than that.
Right. It's a combination of things working together. So we've got this mechanical entrapment. Just simply the gaps in the filter material are smaller than the particles, so they get stuck. Pretty basic. But then there's this thing called adsorption, where particles actually kind of stick to the filter material itself. It's almost like static cling.
Oh, interesting. Like a magnet almost.
Yeah, kind of. They're attracted to each other in a way. And then the third mechanism, this is a cool one, it's called inertial impaction. What happens is bigger particles, just because of their size and momentum, they're heavier, they can't follow the twists and turns of the liquid going through the filter as easily as the smaller stuff, so they end up bumping into those filter fibers and getting stuck.
Oh, that's so cool how all these different forces are working together.
Right. It's pretty amazing.
So does that mean different types of depth filters are better for different particles? Or is it more about just how much stuff you need to filter out, like the total load?
It's a little bit of both. I mean, you do want to choose the right filter for the job, of course. But let's talk about the different types. So the simplest kind are called packed bed filters.
Packed bed.
They're basically just columns, like tubes filled with granular material. Sand, sometimes, or diatomaceous earth, things like that. Pretty basic. But then we've got cartridge filters, where the filter media, the stuff that actually does the filtering, it's pleated or wrapped around a core.
Why pleated?
That pleating, it's all about increasing the surface area. So it's like packing more filter into the same space, which means more trapping capacity before it gets clogged.
Ah, that makes sense. More surface area, more stuff it can hold before you have to change it out.
Exactly. And then there's another kind, filter sheets.
The other sheets, okay.
Yeah, these are like flat sheets of fibrous material. They're used in things called plate and frame presses. You can basically stack them up to create a huge filter surface in a smaller space.
Oh, so there are different tools for different jobs, basically.
Precisely. So now that we know what they look like, where do these workhorses fit into the big picture of biotech? I mean, why do we care about this stuff?
Right. Well, our material talks a lot about pre-filtration. So it seems like they play a huge role in the early stages of a process. They're grabbing all the big stuff, the cell debris, the large particles, for things like fermentation broths. And this happens before the broth goes to the more sensitive, expensive downstream purification steps.
Yeah, like a bouncer at a club. The depth filter is standing at the door, keeping out the riffraff, so the VIPs can get through to the real party. And those VIPs, in this case, they're your delicate and costly membrane systems and chromatography columns.
Right. Makes sense. It's protecting the more sensitive equipment from getting overloaded, breaking down.
Exactly. You don't want those expensive systems to get clogged up and fail prematurely, so you use depth filtration as a sort of first line of defense. It's all about increasing efficiency and saving money in the long run.
So it's not just a rough cleanup, though, right? This depth filtration.
No, you're right. Our material also mentions clarification.
Clarification. Okay.
Yeah. It's another key application. Depth filtration is also really good at just making liquids clearer by removing suspended solids. This is particularly useful when you're working with liquids that have a really high load of particles to begin with.
Makes sense. So what are the main advantages of using this method then?
Well, for starters, they can handle a ton of solid material. That high loading capacity is a big plus. They're also relatively cheap compared to some of the more advanced techniques out there. Operation is pretty straightforward, and they can even handle thick, viscous liquids, which can be a challenge for other filtration methods.
Sounds pretty awesome. But are there any limitations to this technique? There's got to be some downsides, right?
Well, yeah, there are some things to keep in mind. Compared to something like a membrane filter, the separation isn't quite as precise, especially when it comes to very fine particles. You might still have some small bits slipping through. And it's not a sterilization method, so it won't remove all microorganisms.
Okay, so you can't rely on it to create a totally sterile product.
Right. And like any filter, eventually it's going to get clogged up, and you'll need to either replace it or clean it.
Okay, so it's more about that initial bulk removal of particles rather than
Yeah.
trying to get a perfectly pure product.
Exactly. It's about getting the process started on the right foot and making sure things run smoothly downstream. It's a pre-treatment step, essentially. It's
Yeah.
all about optimizing the entire process.
So what you're saying is it's like a layered approach. You start with depth filtration to get the big stuff out of the way,
Mhm.
and then you use more advanced methods later on to really refine and purify the product.
You got it. And that, I think, is a really key takeaway for our listeners. Understanding depth filtration shows you how even in cutting-edge fields like biotech, these industrial processes, they often rely on smart combinations of different techniques, each one playing a crucial role. It's all about working together.
Right. So even though depth filtration might seem kind of basic at first glance, it's actually a really essential part of the whole process.
Absolutely. It underscores how even something seemingly simple, like a separation principle, when applied strategically, can be fundamental to producing these high-value products that we depend on, whether it's medicines, biofuels, you name it.
All right, so let's just quickly recap the main points here. Depth filtration, your go-to for cost-effective initial particle removal in bioprocessing. It works by trapping those particles within its three-dimensional structure, unlike a simple screen filter.
And it really excels at pre-filtration, getting rid of all that big debris and clarifying liquids that start out with a high concentration of solid particles.
Exactly. And it's that crucial first step that protects the more advanced purification methods down the line, making the whole process much more efficient.
Absolutely. Efficiency is key.
So here's a little something to think about as you go about your day. Think about other processes, maybe in your everyday life or other industries, where there are multiple steps involved. What are those initial steps? The ones that might not seem as glamorous, but that pave the way for the more sophisticated stuff to happen? Sometimes looking at the why behind those seemingly simple stages can really help you understand how these complex systems actually work.
Yeah, it's all connected. You pull on one string and you start to see how the whole thing unravels.
Exactly. And that, my friends, is the beauty of depth filtration.
And the beauty of engineering in general, right?
Absolutely. Thanks for joining us.
See you next time.
See ya.